Okay, formulas and literal equations. We're going to solve these types of equations exactly the same way that we have done with only one variable, except they will be containing more literal numbers. And here's an example of what I mean. It's a formula. Distance equals speed times time. Okay? So we say in math we call this a formula that is solved for D. All right? It is solved for D. So this means that if I substitute in speed and multiply by time, that will give me my distance traveled. So sometimes we need to solve an equation for a different unknown. So how about we need to solve for t? Perhaps we know distance, we know speed, we would like to calculate time. So you want to ask yourself, what's happening to t? What is happening to t in the equation? And how do I reverse that? All right, so what's happening to t? It is being multiplied by s. Remember in some of the equations we looked at, we had a number equals something like 2x. How did we reverse the 2x to make it just 1x? Well, you want to divide by whatever that value is. So over here, distance equals speed times time. If I would like to isolate t, meaning I want 1t, I need to remove this s. Reverse this multiplication by speed by doing the opposite operation. Divide by speed and divide by speed. Always do the same operation to both sides of the equation. Notice what happens here. Cancels because they become a 1. Right? So t equals d divided by s. This equation has now been solved for t. We could do the same thing. Solve for s. Distance equals, speed times time. What if I want to solve for s? What's happening to speed? Well, it's being multiplied by time. And in order to reverse that, we would need to divide by time. Divide by time. And so these cancel each other out, leaving speed equals distance over time. Now I've switched sides on the equal sign, but that you don't have to do that. It's just because I like to have my literal number that I'm solved for on the left. But it really doesn't matter where it ends up. It's wherever you like it to be. Okay, so here we're going to go through another example. How about one that looks like u equals negative EL all over 2m. And let's try to solve this equation for capital L. Okay? So if you look at what's happening to L, L is being multiplied by E, and we can even think of it as being multiplied by negative E, and then that product is being divided by 2m. So if we want to isolate L, we'd like to reverse this, okay? So the last thing that I said was happening to L was that it's divided by 2m. So that's the first thing I should probably do, is reverse this. And also I always recommend eliminating any fractions in any equations by multiplying through by that denominator. So let's see how that looks if we do that. So we've got a u on this side. We are going to leave our okay, there's our equation. I want to move this to the other side of the equation. It is divided on this side, so we need to multiply by 2m on this side and multiply by 2m on this side, because the 2m over 2m cancel each other out. So that leaves us with u 2m, right? Looks funny like that. It really 2mu might be better actually. Let's change it to that. Usually put the numerical part first. Okay, so let's call that 2mu equals minus EL. Great, got rid of the fraction. Always multiply through by denominators and you will eliminate fractions, and it's better when you do. I'd like to isolate L still. I need to look at what's happening to L. It's being multiplied by minus E, and so the reverse of multiplication by minus E is to divide by minus E, divide by minus E, and we will cancel the negative, cancel the E's, leaving L. So 2mu over negative E equals L. Sometimes you don't see people leaving negatives in the denominator. We can always just move that up to the numerator. This negative is actually a negative fraction. It doesn't have to be just in the denominator or just in the numerator. We can have it minus 2mu over E equals L. Okay? Okay, a couple of last minute things that I want you to keep in mind when working with formulas or literal equations is to recognize whether the literal number is a capital or lowercase, okay? Caps or lowercase. It matters. If something is represented with a capital letter, it should be represented with a capital letter all the time in that particular formula. Because what happens is in some formulas maybe you will have a lowercase t and uppercase T, and they represent different values, okay? Different. So we don't want to just write everything with caps like some people sometimes do in their own handwriting. So the case of the letter, whether it's cap or lowercase, is very important. Also, you might see related values written with subscripts like a G1, a G2, all right? These are different values of a similar type of nature, but the subscript is very important, okay? So watch for subscripts. These are not the same, they don't represent the same unknown. They represent similar related values, but not the same ones. And then always remove brackets before trying to solve. What? It's not spelled right. Always remove brackets. And always eliminate friction. I can't write tonight. Alright? Always get rid of fractions. By dividing by the denominator. By multiplying. By the denominator. When I say that, I mean multiply every term by the denominator. That will eliminate the fraction. If you have more than one fraction, well then you can go through again and multiply through by any other denominator. Okay, so I hope this gets you started. Have a look at these two sections. We had 1.10 and 1.11 in here. 1.12 is just some applications. Okay, so there's some practice in there of word problems too. Have a look at those. Thanks for watching.